Denver with this Diablo. How many people know how to use a Diablo, a Chinese yo-yo? A couple of people over there. So that is good. Now I have to tell you, I need to take my glasses off for this because I've got these progressive glasses. So every time I do it, it goes like blurry clear, blurry clear, blurry clear. Blows my mind. I would rather just have it be like blurry the whole time, except for all that switching around. But I worked down in Space Odyssey, our space exhibit, and I wanted to come up. A lot of times, you know, when we're explaining about the seasons, people want to know why is it that the Earth, as it goes around the sun, always points in the same direction. What holds it there? So I came up with this little example of that. I'm going to show you what happens. This is going to be the Earth. I'll be the sun. And I'm going to go around. If the Earth is not spinning, watch what happens. The orientation will keep on like twisting around. It doesn't hold its position at all. But if I start this spinning and give it angular momentum, it holds its motion, it holds it in position. So watch this, you see which position it's in. It'll stay in that position as it goes all the way around the sun. The reason that the Earth stays in its position is because it is spinning. As a matter of fact, I'm going to toss this a little bit in the air, and you can see that even I'll tell you anything for a round of applause. Okay. Okay, well wait, I'll do, okay. So, but you can see that it holds its position. Scientists actually don't know why that is. So they call it conservation of angular momentum. When they have conservation laws, it basically means they have no idea why it works. It's true. So they make it a basic conservation law. Watch the same thing when it's not spinning. It just flips around. I'll see no round of applause for that. That's like, no, that's okay. We're going to go back for the one where you get the round of applause. Hang on a minute. Hang on a minute. This is cool also. You get friction on the bottom, but if you go once around there, you have 1.5 like twist to get that friction. Okay, wait a minute. I'm on a roll now. Now I'm on a roll. Hang on a minute. Okay. Okay, now, oh, wait a minute, this is good. Behind my back. Who said behind my back? Okay, here's what's going to happen. I am going to, this is like a combination trick. I'm going to first toss it up, cross my hands, catch it with my hands crossed, toss it up, then toss it behind my back, then toss it in the front and catch it. But I get 3 tries. For that. Well, they had 3 laws of motion, so I should get 3 tries. Okay, here we go. Whoop, no. Okay, we're good, we're good. That was try number 1. That was attempt number 1. All right. Okay, let's see. Okay, get the spinning. This is what I practice at night in my bedroom. It's like amazing. Okay, there's that. There's that. Oh, yeah! So I was thinking about it, and I realized that you can actually tell how tall things are by like how long they stay in the air. You know that like 1/2 GT squared law? How many people know what I'm talking about with that? Like if you throw something in the air and it only goes up that, doesn't take very long. The higher it goes in the air, the longer it stays in the air. And if you were to measure the round trip of how long something is in the air, then here in the United States, 4, and that's T, 4T squared is how many feet high it is. Because 1/2 GT squared, so if T is the round trip, T over 2 is just the drop, and then it's 1/2 G times T over 2 squared, that comes out 4T squared. For the rest of the world, it's like 1.2 T squared. who can think like that. So 4t squared. So here's what I'm going to do. I'm going to try to shoot this up. We'll see how high the ceiling is. I'm going to do it down over there so that I don't like screw myself up. I need a couple of people who know how to use stopwatches. Who wants to be a stopwatch person? Here's one over there. Give Dave a round of applause. Who wants to be a stopwatch person? Okay? And so what's going to happen, just so that you know, is that you're going to give it the stopwatch a try over there to see how it works. The one button starts it and stops, and the other one resets it. So basically, from the time it leaves the string, it would be start, stop, like that. See what I'm saying? It's sort of like, I'm going to go 3, 2, 1, go, stop. That's how we will do that. Work it. And the reason for 2 is so we can take an average. If other people have stopwatches like on your iPhone and want to try to time it, the more that we get, we'll be able to do that. And Dante's going to be the person who works out with the calculator, etc. The only other thing that I will mention, I'm going to go down there, is that it leaves, it leaves the string about there, which is about 6 feet above the ground. And so once we get our formula, we'll add 6 to it in order to get the entire thing. Toss that up over there. Okay, here we go. You guys might want to back up for a little bit. I'm serious on this. Now I will mention when I do this that it's going to go high. Usually I catch it just fine, but I don't always catch it just fine. So for real, if you see this thing coming at you, we want to do one of these ducking covers like this. It's rubber, so it won't do any major problem, but still it'll, should we demonstrate here on Jonah's head? It'll still you know.
And not a vital organ.
And you might want to, Wayne, back up that camera over there. So seriously, if I say heads up, should we practice this one time? Okay, probably won't happen when I go heads up. Okay, and you guys back over there, I have to aim for you in order to get it. Here we go. I'm going to try this a couple of tries. I'm going to see how close I can get to the ceiling. For the stopwatch people, let's give it a practice run where I go about halfway up. Stopwatch people, and then we'll just practice this once. Here we go. You ready? 3, 2, 1. Stop. Okay, what time did you get?
1.65.
1.65, and what did you get? 1.84, 1.65 plus 1.84 divided by 2, that'll average it, then square it, then multiply it by 4, and what do you get, Dante? You times it, you go times equal. Times equal. What was your number?
I got 2.
1.65, 1.84, you got it, and how many feet high is that? If anybody else has a calculator, you can help out. Say what? 12 feet plus 6, 18 feet in the air. Okay, we're going to go for the height now. All right. And the other thing I need to do is count how many steps back before I trip. Okay, so I can do about 3 steps back in any direction. You might want to back up a little bit, just so in case I have to catch it like that. Here we go. Here we go. All right. Okay. 3, 2, 1. Okay, now I can go higher. We don't want to get it close. That's all right. That's all right. Here we go. Get ready to zero out your stopwatches again. 3, 2, 1. Whoa, yeah. Now we're going to do the calculation. What did you get? 3.02, 2.97, so we'll average those two. Actually, it's almost exactly 3. So 3 times 3 is 9, 9 times 4, don't tell me, 36, 36 and 6, 42 feet in the air, yes. Is that what you got? 42 feet in the air. By the way, I'm going to do this one more time because... Exactly. You're used to reverse Polish notation. All right, I'm just going to do this one more time because when we do it with a big screen, in order to, number one, get a more accurate measurement, and also to give the visitors an idea of different creative ways that you can use scientific instruments, we actually videotape it, and then you play the videotape back so you can see exactly which frame it leaves the string. You can see exactly which frame it hits the string, and that's how scientists would make a very accurate calculation, and then because 30 frames per second, you can do it. So, if you want to try this at home, everybody who's got the iPhone, I'm going to do it right now, you can stand up, get ready with your iPhone to record it, and then when you get home, you can try that experiment. Anybody have like an iPhone, they want to give this a shot, ready to go? Here we go, way in the back over there. This is the last one, and if I get this one, a big round of applause. And even if I don't, give me a break, it's early in the morning, you know? Okay. Here we go. 3, 2, 1.